Software Engineering Radio, episode 48, interview with Dragos Manolescu. Welcome everybody to this new episode of Software Engineering Radio. In this episode we talk to Dragos Manolescu. Dragos is an architect with Microsoft's Patterns and Practices group. I talked to Dragos about architectural evaluation. Architecture evaluation is about finding out whether an architecture suits all the needs of the various stakeholders that are involved in an architecture. Before we actually start with the interview, I wanted to point out that this interview has been recorded at the JAU conference. More specifically, it has been recorded in the restaurant in the hotel. And you can hear that because in the background there is some guy cleaning up the dishes and making noise. I don't think it's really bad. You can still easily hear what we are talking about. Just wanted to point out what the background noise is all about. So let's get started. Welcome, Dragos, to this episode of Software Engineering Radio.
Hi, Marcus. Thank you. Good to be here.
Yeah, welcome. No problem. So architecture evaluation. So what is it about? And what is architecture for that matter?
Oh, I'm not going to open that can of worms. I learned my lesson a while back. It seems like nobody agrees what architecture is, and if you ask different people, you're going to come up with different responses. And I usually use as an excuse the fact that if you go to the SEI website and you look around, we have a long list with definitions. There are 50-some or 60-some definitions. So rather than my incrementing the number, I just send you there and you look at it. But I'm
we'll
pretty
put
much
it into the show notes.
Yeah, I'm pretty much in agreement with the definition that the SEI folks have given. I like actually their work in this space, and it revolves around the components and the interaction between between these components and the properties that the components and the connectors between the components have. You'll find it there.
Okay. So architecture evaluation then probably has to do with kind of evaluating whether the structure, the components, the interactions of the system are able to meet some of the requirements. And
that's right. As our systems have changed significantly since about 10 years or 15 years ago, many more concerns are on the table now. So if you think how you were building systems back in 1985 or even 1981, you weren't that concerned about multiple users, distributed computing, networks, security, and so on. Well, those things have changed. Now, most of the systems that I build, and I'm sure that the ones that you're involved with as well, involve web and distribution and multi-users and multiple servers and so on. So once you bring all these concerns to the table, you need to be careful about how you partition the functionality in your applications, how they communicate with each other, how they interact, and the interplay between these components to achieve critical goals that you are expecting. And architecture evaluation deals with providing you a chance to assess how well does the architecture support the characteristics that the business people or whoever the customer is may not be an architecture built for business people, for business purposes. So how closely does the architecture meet those goals? Those goals are things like performance or security or conceptual integrity, if you want to get towards more the more esoteric ones, or subsidiability and so on.
So you're dealing more with these, what many people call non-functional requirements, kind of?
That's right. There's a lot of non-functional requirements. Architecture evaluation doesn't really focus on functionality per se. Okay. That's something that you would involve different techniques. Architecture evaluation deals with verifying that the functionalities have been carved out correctly.
Which would be the functional requirements?
The functionality of the components. So I have a component that implements caching. I have a component that stores information like a database. I have a component that deals with user input. These are the components, and I want to make sure that the way I have partitioned the functionality between these components does not hamper my achieving some of the architecture goals, or these ilities, if you will, the non-functional characteristics.
We've talked about these in previous episodes extensively, so our listeners know about them.
Good.
So let's try to do this systematically. So what are some of the preconditions or prerequisites that projects must have or show in order for architecture evaluation is useful or feasible?
Mm-hmm. So there are several. It probably helps to step back and look at when would you want to evaluate an architecture
and why.
Correct. And there are multiple places in time where you want to do that. Ideally, you do it once you have made some of these significant decisions, and you want to validate that they are the right decisions. And before you've written reams of code, and the cost of undoing what you've done becomes prohibitive. There are other places in the life cycle of a product when you would want to do this, and they would be later on when things don't seem to work as planned. Typically, people call on others to evaluate their architectures and validate their design choices and so on, all the way to the end. But no, the closer you get to the end, the higher the cost of making the change is going to be.
If you say that you should do this ideally as early as possible, which is obviously a useful thing, then this requires you have some kind of upfront architecture design. So you have this, big upfront design before you start implement. How does this go together with agile development, where you don't really do this?
Actually, it doesn't require big upfront design. It requires some thinking. It requires some thinking ahead of time. And let me first walk you through the process, and then let's make a note to get back to it, because there's a very close parallel between architecture evaluation and agile development that I would like to emphasize. This is actually a question that many people ask me about, and let's revisit that topic later on.
Okay.
So inevitably, you typically would like to evaluate your architecture earlier to make sure that the design choices that you've made are sound and they are aligned with whatever the stakeholders of the architecture want. And there are several prerequisites for this. One prerequisite is that you have some understanding with the people who commission the architecture about what is that they will get out of it. Typically, people tend to assume that architecture evaluation is something that focuses only on the technology aspects. That is wrong, and you need to reset expectations and explain to them that you will be looking beyond just the technological choices. For example, on some projects that I have evaluated, initially the expectation was that, have a look at my object relational mapping and my database choice and tell me whether those are good choices or not. Well, there's not really architecture evaluation. That's more product validation.
Technology evaluation then, maybe.
Because if you get back to my definition of partitioning of functionality and responsibilities between the components, by the time you already have a database and a cache and what have you, you've already partitioned the functionality. So I can only see whether something matches a particular piece of functionality that you have in the big picture or not.
So you're working more on a conceptual architectural level.
That's
where
right.
You talk about modules and interactions and interaction patterns and distribution instead of X technology and Y technology.
That's right. You can think about it in terms of CRC cards. So one way to think about it is that these modules have some responsibilities. What is that they do? They may be a data repository, or they may be caches that help you save time by storing intermediate results, so you won't have to perform expensive computations and so on.
Yep.
And they also collaborate with other modules.
Yep.
And the amount of collaboration and interaction between these components determines how the architecture would fare up as far as performance is concerned, response time, throughput, security, and so on. So that's a rehash of the definition that I brought up earlier.
Yeah. So another important step, probably you talked before about involving stakeholders, then I guess being aware of who these stakeholders are is an important prerequisite, I guess.
That's right. That would be the second stage. Before we get to that point, let's look at the prerequisites. So the first one was to explain what the expectations are, what the process entails, what the outcome is going to be, so people would have a pretty good understanding of their involvement, the types of artifacts that the architecture evaluation will deliver, and so on. The second thing that you need to do as far as this preparatory work, the prerequisites, is concerned, is reviewing the architecture artifacts that people have. And
like UML diagrams or what?
Yes, the architecture descriptions, because when you evaluate an architecture, typically if you do it early on, there's not a lot of code that you can look at.
Yep, exactly.
But there should be some understanding of the domain, what you're dealing with, of the business case, what's the architecture business what are the architecture business scenario, what are the needs of the stakeholders, and so on. So you need to review that work, and typically you end up doing a lot of work that you would need before embarking on architecture evaluation. Because these artifacts don't exist. Sometimes they do exist. Typically, when people apply processes like RUP, so they start with good intentions. They start with a process that's more or less, accepted out there. They perform the work, and these artifacts exist.
So what are good artifacts? What are good ways of describing an architecture, not just for making it amenable for review or evaluation, but in general? What do you think is useful? Is UML useful, or are meta models, architecture meta models, a good thing, or any ideas there?
Well, the UML is just a representation of an abstraction. So if just one representation is sufficient for the particular abstraction that the architecture represents, then UML is sufficient. However, in practice, just one representation for the abstraction that is represented by the architecture is not sufficient. You need more. So other things that I've seen in the past would be, besides UML views that show you the components and the relationships between them and the way they interact, so static and dynamic views, would be an articulation of the architecture business cycle. So how do we get to building the architecture? How
rationales?
Yes, exactly. The vision, the envisioning, the envisioning stage of the process. As well as all these views and assumptions and constraints that the architecture must deal with. Some assumptions may be revolving around who's going to be performing the work, what kind of skill sets they have. Some constraints may involve components that you already have in-house and you want to use or you have to use, and so on.
So that's primarily plain text stuff then.
How this information is formatted or represented doesn't matter.
No, in theory it doesn't, but in practice you have to extract the knowledge about the architecture somewhere, and there might be renderings that are more suitable because they're more formal, or others, So, you have to write it down somehow.
Right. So as far as the formatting is concerned, you will notice a wide variance not only on the quality and depth of this information, but you'll also notice a wide range of artifacts. You could have something formal, like UML diagrams, or you can have something very informal, maybe diagrams on the back of an envelope. Now, that would be an extreme case, but there's not a specific format. Just be prepared to deal with this variance. So then the other thing that you need to look into as far as this meeting the prerequisites is concerned is to go beyond the step outside of the IT department and see what exactly the drivers are behind the architecture.
Business drivers, kind of.
In many cases, unfortunately, if you take a closer look, you will see that the drivers behind building a new architecture are purely technical. Sometimes the IT just is looking for an excuse to play with a new tool, experiment with the new technology, play with frameworks, and so on. And take SOA. Many projects these days, they embark on SOA without having a really, really strong need.
Although everybody says that SOA is business driven.
Yes, but if you look at it, and this happened to me on many instances while performing evaluations for various clients, just starting to look into the architecture quickly becomes very clear that the business is not really interested in exposing their services to trading partners. They're also not interested in outsourcing the functionality that the business entails right now to outside partners, and they don't really think in terms of business processes that they want to change very, very quickly, because maybe it's a business that has a long way to go to articulate these business processes. So in that case, trying to drive down this nail with the SOA hammer is going to be a waste of time and resources.
So understanding the motivation for an architecture, even if it is that the IT department wants to play with it, which is also, to some extent, okay, if everybody agrees that this is a good thing. Understanding these things is probably the most important thing in order to be able to evaluate the architecture.
Absolutely. The IT is a big part of the picture, but they're not the only stakeholders. Architectures have multiple stakeholders. The IT is an important player, but there are other stakeholders. And if it turns out that the IT's concerns are the prevalent ones, then it's okay to just satisfy those requirements and go with whatever direction they want to pursue. Typically what happens, you get multiple viewpoints and try to find a median point that satisfies all these stakeholders. And we'll talk about it later on.
Yeah.
So other things that you want to do is to make sure that you connect back to the business problem. Even if the architecture business case has been clearly articulated at the beginning, what happens in time due to erosion or just plain attention deficit disorder from the side of the IT is that this business case gets distorted and forgotten, and people no longer are thinking in terms that have been articulated in the past. So if you find yourself on a project that has some work done on this front, try and revive it back, pull it out, and make sure that it's still valid, updated, and people are still aware of what you're dealing with.
So that means also involving the non-IT stakeholders all over the process. One classic I think I know from my projects is that the deployment and operating folks are typically ignored until right to the end, where you want to deploy or put your system into production, and then you have all these kinds of surprises where they say, you can't operate this, we're not supporting this or that technology. So having them involved all the time is probably a useful thing.
Absolutely. And that would be the second step. So once you set the expectations and perform this preparatory work, the next step is to find out who all the stakeholders are and figure out what their concerns and their goals as far as the architecture is concerned are. So you should also look way beyond IT, find all the business stakeholders, and there are some typical roles that get left out. The one that you already mentioned would be the ops guys. Typically, they get left out. They don't have a big say, though they will be the ones receiving the page in the middle of the night to go and replace the CPU board. And another class of stakeholders that get left out typically from these evaluations are the developers who will be maintaining the architecture once it is developed and deployed. Typically, that's a different group, but although they have a stake in the architecture and how easy would it be to maintain the architecture, how easy would it be to localize problems and fix and modify areas and so on, they are not represented typically.
Yeah, often they're not even yet known at this time.
That's right.
Personally.
That's right. So in many instances, when you ask for a list of the stakeholders, people don't really have anything ready. Based on my experience, other times, even if they have it ready, this list is incomplete or outdated. So should you find yourself in a similar situation, my recommendation would be to revisit this list and go through the motions again and make sure, revalidate it basically. Make sure that everybody who should be on the list is on the list and that you get to meet them all. Otherwise, it is impossible for you to establish a connection with the architecture stakeholders who will help you in establishing the evaluation criteria. That's basically the whole idea behind architecture evaluation and stakeholder involvement. You leverage the stakeholders to define a custom evaluation criteria that varies from architecture to architecture, because the architecture supports all these stakeholders, and you can't really pull out a set of canned evaluation criteria and measure architectures against these canned criteria. They are defined for each architecture with the stakeholder. Another thing that you need to do is to sense whether the architecture has been commissioned just for show, because knowing that gives you insight into the relationship that you have or you won't be able to have with the stakeholders. Sometimes, and this is sad but true, sometimes you get called in to perform an architecture evaluation just to justify decisions that have been already made or things that people are building already.
So this is like if you want some statistics and statistical analysis, you'll always find out what the customer wants to have. So if the customer says, this is a great architecture, please convince our critics that this is great, then that's a different situation as if you have to do an objective evaluation.
That's right. So typically what happens, you get called in to evaluate an architecture, and as you start figuring out the landscape and who the stakeholders are, what are the business drivers behind the architecture and so on, you will realize that the architecture construction stage has started already. and you got called in the middle because due to increased pressures or schedule slipping or questions about the whole project, someone wants to find to find a justification for their building the architecture or find an objective endorsement for their building the architecture and the quality of the architecture. And of course, if this is the case, I'm not saying you shouldn't do the architecture evaluation. You should. Your goal is to help whoever's building the architecture and making sure that
paying you, right?
Well, that's
depends.
That depends. Sometimes you may turn them down even if they offered to pay.
Yep.
If these prerequisites that we covered are not available and they would not help you to satisfy them, you should just walk out.
Yep.
But the idea here is that if you understand exactly the forces behind the architecture evaluation, you would have a better grip on your relationship with the stakeholders.
Yeah.
Because it's very different if you step into a project where they just need an objective third-party evaluation for things that have been decided or commissioned already.
Yep. A lot of psychology also.
Absolutely. Absolutely. There are many traits that you would notice. One of the most common ones is that if the evaluation has been commissioned for show, not everybody will welcome the evaluation team.
Yes.
And this has happened to me more than one time. Whenever this happens to you, try to establish a good relationship with these folks. Explain to them that you are not there to take their job or to prove that they're wrong. You're there to help them identify risk early on and help them provide a working architecture at the end of the day. So you will help them look better when everything settles.
Yeah. So how do you perform the evaluation itself? I mean, of course, we talked about looking at the architectural documents, at interviewing stakeholders, talking with them. Any tool support available? It's kind of the obvious question.
No, unfortunately, this is an area that needs a lot of work. If you are an architect and you're looking for options as far as tools are concerned, you can find quite a few options out there. If you're a developer and you're looking for an IDE or other development tools, you have lots of options. If you're a tester, you have lots of options. But what options do you have if you're an evaluator? Not a whole lot.
Yeah.
I'm aware of very few, maybe a couple of products that claim that they are architecture evaluation products, though if you take a closer look at them, they're not quite there yet. It's a big step forward. And the reason I'm saying that they're not there yet is that most of the analysis that they help you with are static. So they would analyze the static structure, the static dependencies between the modules,
like
the
for
components.
example, software tomography.
Like that, stuff. Yes, exactly. Like software tomography, and there's another product I'm aware of.
Yeah, but
does the same thing.
But also, it works on source code, so it can be used only in later stages. It expects that there already is code to analyze. It's not the same thing that you talked about.
That's right. Plus, that kind of product and the other that I'm thinking of has the same problem. Works only for architectures where you have the source code for the entire thing.
Yes.
Well, in real life, if you're looking at enterprise applications, you have off-the-shelf components that you don't have the source code for.
Point. Yeah.
You have legacy components that even if you have the source code for, nobody understands it, or these tools won't be able to parse or to find.
Yeah.
You have outside vendors that provide you with a service interface or something like that you're using, and these tools would fall short in helping you expand the analysis beyond these boundaries.
And also what I found, I just saw a presentation on some of these tools these days, and what I found a bit strange was obviously they can only work on the abstractions that are somehow represented in the code, like package dependencies, class dependencies, and yes, you can define things like subsystems using directories or something, but there is no architectural meta model with rich definitions of the concepts and building blocks you have available. So the conformity of the code, of checking whether the code conforms to a certain architecture, is very limited to a number of limited concepts.
That's right. These tools tend to require your defining some constraints, and then they verify that the information that they can pull out of the source code meets or doesn't meet these constraints. The key challenge with these tools, though, remember from back to the beginning of our conversation as far as architecture is concerned, these tools don't tell you anything about how these components communicate at runtime. Right. So the fact that I have a dependency that doesn't violate any constraints between two modules doesn't mean that architecturally this is sound. What if the communication between these two modules is very expensive? And I'm
Right,
looking
like
at
if it's distributed.
right, and I'm looking. I have a very very expensive channel between the two components,
Yes.
and I'm looking at achieving performance that's measured with sub-second response times or some high throughput. Well, those tools are not going to help me figure out this problem.
Yeah. So the only tools that are probably going to help you are like the generic tools like wikis, Excel, maybe a requirements management tool to sort through the requirements.
That's right. In the absence of tools, you're stuck with without any tool support for architecture evaluation. But don't give up. I have successfully used generic tools for architecture evaluation, and there's a set of ubiquitous tools that the chances that they're already installed on people's computers are very high, and they would be Word. I used Word templates very successfully for architecture evaluation and capturing evaluation scenarios. Excel. Used it very successfully for also capturing the outcome of the analysis and presenting graphs that show different things coming out of the architecture evaluation. Even Visio, there are people who know how to use Visio. Non-technical people otherwise who know how to use Visio, and they would be able to sketch a diagram or a graph that you're interested in seeing. And using these generic tools, besides the fact that chances are very high that people already have them on their computers, has another advantage, and that is a very, very low learning curve. Most of the times that is zero. Other times maybe some hand-holding a little bit to get them going with filling in some templates that you have provided. But that's all about it. There are no licensing implications if the people have Office installed or any other generic tools, and they're there to help. Yet another thing that I recommend doing, and I could give some examples with tools that I have been successful with, is the use of other generic tools that may not be part of this common or ubiquitous set, but people are likely to have. Such as mind map diagrams.
Oh, yeah.
One of the artifacts that comes up in when you perform evaluations that follow the architecture trade-off analysis method, which is one of the methods from the SEI.
And we'll talk about this in a minute, I guess.
It's called a utility tree, and this utility tree, imagine a tree slanted 90 degrees counterclockwise, so the root is on the left-hand side, and then it expands with the leaves on the right-hand side, and it shows you the architecture goals and refines them, and then it boils down to scenarios. Well, a mind map diagram is very, very useful for capturing all this information, and any mind mapping tool would help you put up these diagrams very nicely, with the advantage you can selectively collapse nodes and navigate and so on. So keep your eyes open for any other tool, any other generic tool that, though it hasn't been thought of as a tool for architecture evaluation, would be handy.
One could argue that architecture evaluation is mainly about structuring and systematizing information in order to have it evaluated. So all kinds of tools that help you but structuring information are probably useful.
Well, again, this is a representation of an abstraction. We're abstracting out a selection criteria, an evaluation criteria. And depending on the tools, we can use a particular representation or another. The utility tree makes it easy to have a big picture with these are my architecture concerns, and this is how they boil down into concrete scenarios. Evaluation outside of a particular context is meaningless, because in some context, a particular value for response time would be good, whereas in another context would be appalling. So utility tree and all these artifacts help you articulate the evaluation criteria in a concrete context.
So let's maybe briefly talk about the ATAM, the architectural trade-off analysis method, right? It's also some stuff the SEI folks came up with. What is it, and is it useful?
The SEI folks have been working in this space for over a decade, and they have produced quite a few methods. I think the first and the oldest that comes to mind is SAM, the Software Architecture Analysis Method. And this is a method that caters to evaluating modifiability and flexibility, and it's particularly useful when you want to do side-by-side comparison. There are other methods coming from the same group. ATAM stands for the Architecture Trade-off Analysis Method, which is a successor of SAM and focuses on trade-offs made by various design decisions made by the architect when they picked one solution versus another. And another one that comes to mind is quite popular is the CBAM, the cost benefits analysis method, which takes over where the ATAM method stops and plugs in economical factors as well. So you have evaluated and you have identified a set of architecture strategies for meeting some goals, some quality goals for the architecture. Then the question that you ask, well, can I pay for all these things? There are costs associated with everything. For example, you could integrate with a bus, you can integrate with a broker, and you want to see, well, what is the cost associated with each of these options? Now that it makes technical sense. And that's where CBAM comes into place.
And how is ATAM different from what you just talked about? Is there any specifics that go beyond what we just talked about generically?
The points that I covered so far are applicable across several methods. I have distilled these points from evaluation using SAM as well as ATAM. What these methods have in common is that they're all scenario-based evaluation methods. You're not going to get a very precise answer. It's not like a simulator that you plug in a description, like a description of a circuit, and then you simulate and you get very precise measurements. This is more of a back of the envelope. Let's identify the architecture risk and see whether the design decisions made are supporting the architecture goals. So that's what all the methods have in common. They use scenarios as a vehicle for exploring and pressure testing various parts of the architecture. Otherwise, they have slightly different goals. ATAM focuses on trade-offs, SAM on modifiability, and CBAM on the economics.
Let me try to connect this to some of the stuff I'm working in, like model-driven development. Now, I see obviously in this architecture evaluation there are two aspects. One is checking whether an architecture conforms to requirements and the stakeholders' opinions and these kinds of things. Formalization probably won't help there because you have to talk to people. But on the other side, if you want to find out whether, like for example, if you have like these two components and they're distributed and still there's timing requirements, is it a good idea to distribute them, cost, performance-wise? Would it help, in your opinion, if the architecture was really formally defined by having a meta model that defines the concepts and abstractions, like what is a component, what's a message queue, how do you define an interface, how do you associate component instances with computing nodes or whatever, and then if you'd have instances of that meta model, i.e. models, that actually really show there is this component with these operations, would that help in analyzing the technical aspects of the architecture evaluation? Obviously not the more people-oriented ones, but would that be useful? So would a more structured and formal approach to describing a system's architecture, not in terms of source code, but in terms of higher level abstractions, would that make this stuff simpler?
Certainly, and as a matter of fact, when you perform either SAM or ATAM, and you're looking at particular architecture goals like performance, you have the luxury of employing some of the theory that is available in this space to analyze performance, for example. And you would use queuing theory, where there's a small set of parameters, like the arrival rate and so on, that if you can figure out what they are, then there's a set of techniques that would help you modify them and get to levels that are within your goals. However, the challenge with the generic system that you're evaluating is that there are so many choices and options. It's very hard to come up with a model that would cover everything. So what happens for other architectures, let's say for architectures for embedded systems or for small domains, for those domains, you can actually have models exist already, and there you can get a much better evaluation that is...
Like state machines. State machines can be simulated easily.
That's right. You can get a better evaluation for particular domains where you have models available. The challenge with that, though, is that is a small number of domains, and typically these are telecom switches or things that people have been building over and over again. You know the requirements, you know the typical problems and the typical quality goals that you're interested in, and you have these models available. However, for your generic, application, enterprise application that you're involved with, it's hard to come up with a model because they're so the variability is so high. What you do, you isolate particular areas like performance or security, where you may employ a thread model or queuing theory for performance and so on, and use these modeling techniques in selected areas where you can actually go and drill into.
Actually, I'm when I work in these kinds of areas, I actually try to do this in a model first approach and then generate stuff from the models so that you can do meaningful analysis on the model level. And that, in my view and my experience, this actually is a big step. Of course, if you have the wrong meta models and the wrong models, this is still a bad architecture. So you still have to do the evaluation, but you might have higher level abstractions on which to evaluate.
That's right. The more areas you can model in the architecture, the more accurate your results are going to be.
Right. Okay, so let's come back to this point we talked about, or we just briefly visited in the beginning, which was agile. So if you say you want to evaluate the architecture before doing all the work and implementing it, how does this go together with we don't need architects, we're all just a bunch of happy developers thing where the architecture evolves over time?
Well, back to your last statement, that I think even the people behind XP, like Kent Beck, have reviewed their statement that architects are not don't have any place in XP in the second edition of their book.
Yes, I know.
But typically what happens on Agile projects, I tend to recommend architecture evaluation right at the end of iteration 0, where you have spiked a few areas and you have an approximate idea of how your system is going to look like. Yep. You've made a few component selections. You've made a few design decisions. You're in a good position now to pressure test these decisions and verify that your assumptions are correct, the design decisions that you've made are sound, and so on. So let me try and draw a parallel between Agile and architecture evaluation. The one thing that we covered quickly earlier about architecture evaluation is stakeholder involvement. Yeah. Well, if you look at what XP and Agile development preaches and recommends, they recommend the developers working hand in hand with customers. Yeah. So you're involving the stakeholders whenever you are evaluating the architecture, is just extrapolating the same principle to the architecture land. Yeah. Another area, and I haven't talked about that yet, but this is a good time to bring it up, is that if you look at extreme programming, you always have tests. You start with tests, and you have what the success criteria is, and then you're going to write code towards meeting that the success criteria towards your having the test pass. Well, for scenario-based architecture evaluation, one of the key elements that you capture for each scenario is what is the response measure? What kind of response do you expect from the architecture to declare that you have met this performance criteria, you have met this security criteria? So drawing a parallel between the two, again, you see that having the scenarios would correspond to cards, to stories, however you want to call them, and each of these scenarios has a measure that corresponds to the test. So you can think of doing architecture evaluation as employing TDD at the architecture level. Here are some goals that I want to meet, and
Except that you don't do it before, you don't afterwards, or as you go along. It's not that you're first evaluating and then implementing. It's like it's in test-driven development. You first write the test, then write the code. That's not the case here.
That's right. If you're evaluating the architecture, you are employing it after the fact.
Right.
However, in an ideal world, and this is what I'm hoping to see once people start embracing architecture more in a different manner they've been doing architecture so far, is you sit down with the architect and start writing up these scenarios, and they say, wait a minute, I already have this stuff, and they open their drawer and they see all the scenarios, because the techniques that I have discussed so far, assembling scenarios, articulating how you measure the architecture meeting these measures and so on, are not restricted to evaluation per se. That's what I do for design as well. So in an ideal world, the architect would have that already, and it would be a done deal, and I would be a happy evaluator when that happens.
Probably doesn't happen too often. Okay, is there anything else you want to say about architecture evaluation?
The whole Agile, how is this not waterfall area comes up over and over again, so I'm glad that we covered it. But I hope that by now you and others who are listening to us have noticed the parallel between architecture evaluation and Agile development, have seen the value in verifying these design choices early on for the interest of saving costs and not having developers work on things that will end up being thrown out. The other area that I wanted to mention here, which is also important and unfortunately neglected on most projects, is the capturing of constraints and assumptions. As you assemble these scenarios, you will start growing a list. These are assumptions that we've made. and this list will grow and will grow as you evaluate the architecture. And while at the beginning that may not come in as very useful, it's like writing unit tests. At the beginning, the ROI is low, but as the number of tests increases, then you can you're in a much better position to go off and refactor your code.
Yep.
Well, same thing with architecture. Once you start growing this list of assumptions, as soon as something changes, the requirements change, the business environment changes, the technical environment changes, you go back to your list of assumptions and see, okay, which of my assumptions have been invalidated?
Yep.
If you find anything, you trace back to the architecture evaluation scenarios where you made these assumptions and rerun the analysis and see whether it is worth your going back to the drawing board to maybe redesign a piece or revisit a design decision. Or not. This is a very important aspect that many people are not aware of, and projects fail because of wrong assumptions.
Yeah. Okay, so before we wrap up, I'd like to mention that we're actually doing this at the JO conference in Aarhus in Denmark, and we just had lunch together. And during lunch, we talked about how we could increase the sales numbers of a book we wrote together, which is the Plop D5 book. So I thought let's just put in a plug quickly. Maybe just describe the Plop D5 book briefly and why people should get it.
So Plop D5 is the most recent installment of the Plop D series, which gathers best pattern papers submitted at Plop conferences. And the two of us with James, we worked hard on assembling an interesting melange of pattern papers in Plop D5. And we have some interesting areas. There's always the area of telecom, which I had a very interesting discussion earlier today over breakfast with someone else here at JAO, which revolved around telecom and how we always run up to the telecom systems to find inspiration whenever we need to deal with high performance systems, whenever we need to deal with high availability systems, whenever we need to deal with large scale systems, and so on.
So you're saying these patterns are not just interesting for telecom folks, but rather more generally?
That's right, because people go and knock on the telecom door whenever they run into problems that have been solved in the telecom world years ago, and only now with our building distributed applications and supporting lots and lots of users, we're running into. There are some other interesting areas. There are patterns on writing patterns, which a lot of people are doing these days. There are patterns on making systems very flexible, like applying ideas from prototype-based languages into systems that are built with regular object-oriented languages like Java or C#.
Yep.
And what else do you remember from the book? It's been a while.
Yes, that's actually the problem. I think what's interesting in the patterns community as a trend is that we're kind of going away from these design pattern-y kind of things that we all know from the Golf book. So if you want to see how the community developed and what areas patterns have penetrated into and where they're useful, I think that the Plop D5 book, as well as some of the other Plop D1, 2, 3, and 4, obviously give you a good overview. So that's certainly an interesting aspect too.
And the other thing that it's worth mentioning now is the way the Plop D books have changed. So if you look at the first two books, you see most of the submissions, most of the chapters in the book are individual patterns.
Right.
As you go to Plop D4 and Plop D5 now, the majority of chapters are pattern languages. So as the field has matured and people have a better understanding of the power of patterns, how to use patterns, and how to write patterns, we have shifted from individual patterns to pattern languages, to the relationships and the connections between patterns that have been harvested from different domains.
Yeah. So, in short, consider getting the book. I think for each of them, this gives us the equivalent of 1 pint of beer, I guess. So we're not getting rich from that, but spreading the message is probably useful.
Yep, definitely.
Okay, Dragos, thanks for being on the show, and
thank you. We'll be in touch.
Yep. Bye.
Bye-bye.
Thanks for listening to Software Engineering Radio. If you want to get more information about Software Engineering Radio, or if you want to give us feedback, please go to our website at se-radio.net. You can also contact the team at team@se-radio.net, although we prefer entries in our comments system on the website so other people can see what you think. Software Engineering Radio wants to thank Henning Pauli for the intro and outro music, as well as Libsyn for providing the bandwidth. This episode of SE Radio, as well as all other episodes, is licensed under Creative Commons license. See the Software Engineering Radio website for details.